Is this recording already? Sorry.
It says recording at the top of my screen.
So perfect. Yeah, I couldn't see it. Yeah, welcome everyone to the Cluster Addons meeting. We're looking at Lee's screen, and Lee had one of the action items from last meeting to write a cap for the add-ons integration into kubeadm.
Yeah.
Do you want to take us through this?
Yeah, I figured we would touch some points, and then people are obviously able, free to review on their own and chew things out. But yeah, this is definitely a first pass. It just basically tells you, hey, we're linking this library proof of concept into kubeadm, and we would like to do this. This particular KEP was on the kubeadm 117 planning cycle to get done. So we've started that process. We talk about some of the motivations. So it's cool there's an official Kubernetes place for some of why we're doing this whole add-ons thing now. And with regard to like the actual cluster installers, most of these motivations I think will be similar. I don't know if we want to do like one of these 4 COPs or something with a similar format. But yeah, you can see, oh, well, like upgrade logic commonly gets baked into the binary, and then that's great that it's like versioned inside of the binary, but it causes other problems with maintenance. And then I think the non-goals section in here, obviously we want to be able for like people to install like hardware drivers and spin up a cluster without service discovery and install CNI. These are great things. There's some things we want to support in this KEP, such as the removal of add-ons, as well as perhaps the pruning of add-ons based off of the declaration inside of the API. And then non-goals are probably just as important. And so we've talked before about dependency graphs and that kind of thing. And I think that we should keep that out of scope for now, as well as success conditions for the add-on installer that go beyond just API validity, like being able to apply things to the API server. That's probably where we should stop for this component. If you need something more complex, it should probably be in an operator and exposed state in some asynchronous fashion. But I don't know, some people might have different opinion on that. I just think it sounds hard and is probably not the right thing to do. As far as how validation of component configs work, I can actually link a KEP here. Ross just posted one. And so if you're interested, there's command line validation of component configs. This does have a lot to do with add-ons because the working component standard basically influences how add-ons kind of should be built. And there may be some mechanism interacting between the add-on installer and component config validation in the future with regards to Ross's KEP. So discussion's open for that. And then also important is just that the actual operators themselves are not part of this KEP's deliverable. And then this one I kind of threw in here. We haven't really talked about this much, but basically it's really difficult if you're an app to figure out that you're being removed from a cluster. There's just no hook inside of Kubernetes that kind of explains that. And we all know that like the minute you install something that's Turing complete, it installs something somewhere else, right? So like making apps responsible for cleanup, it's like a really difficult expectation. Usually you need to clean up in like an additive way. Like if you wanted to do it correctly, you'd need to apply some cleanup field to a CRD or something, right? A use case for this would be like cleaning up after IP tables, right? Because you're modifying the kernel under you. And just the current state of infrastructure, if you wanted to like rotate CNIs, like that's like a node reboot of like your entire cluster. There's probably more creative things you could do for that. And then it gets into the actual implementation about an alpha feature gate that is changing behavior in different phases, adding a phase to kubeadm's execution structure. And then I linked to some of the design and user stories documents down here. Some differences in the APIs that we've seen so far is in the add-on section for the particular add-on, I decided to add a name. Adding a name allows us to more strongly correlate what's being upgraded, and then just for things like user output, and then also decide, okay, well, if I were to remove this entry, sorry, if I were to remove this entry, you can tell that I want WeaveNet to be uninstalled, right? And so we can purge it because the name is now missing. And that means that we can change refs without things becoming destructive. So a little bit of UX, you can see the phase can be exposed through or can be executed individually, which we saw on our last demo, as well as through init and upgrade. And then there's also going to be a config interface for interacting with the defaulted portions of the add-on installer. This proposal talks about defaulting and what Kubernetes should do in the case that it is asked to use the add-on installer, but the user does not provide a config, which is basically default to the appropriate add-ons for the cluster version. And then constraints is kind of an interesting one. Basically, the gist of it is that the library would probably be much more mature and have less caveats if we were vendoring customize and we were using some kind of formal API client that could be swapped out for a dry run client. This is a little weird because there's actually, I discovered two kinds of dry run. There's a dry run where you're not hooked up to the API server and there's no cluster. And that should still provide some kind of helpful output for the user to realize that their inputs are sane. And then there's the dry run where there is a cluster and things like kubectl can decide how to tell you if something's being changed and that kind of thing. So supporting that like dual mode of dry run is an interesting like gradient of features. And then I mentioned in here about how like OCI image support isn't something that exists, but it's something that it sounds like people want. As far as like risks and mitigations, what did I write here? Oh yeah, I basically talked about like signing releases and about how SIG release and security might be interested now that we are necessitating that there be new artifacts. Right? This feature is at its core like a packaging proposal, right? And so there are new artifacts, there's new transport, and like there has to be a story around that. So yeah, and then there's a little graduation thing with just like some quick notes of things I thought of. I'm sure that this could be fleshed out much more, but it's pretty early stage kept at the moment. And then some links to our existing work. So, but yeah, does anybody have like any particular questions or like have things that they want to see in here?
Yeah, so can you go back to the API there?
Yeah.
Yeah. So those refs, what exactly is that pointing to?
Yeah, I think this is a great thing to point out. This could probably be broken up into multiple ref types. The most naive thing we can do is take this string and then pass it to kubectl apply -k. So that
you're expecting that's a folder containing a bunch of Kubernetes.
A customizer, yeah. There's in the current add-on installer library, the initial implementation only supports a customizer, and that can come from a Git repo or from a local directory. And then we've talked about expanding the customized support for OCI. And then I think it also would be good to just support a manifest list, right?
Yeah, the latter is the one that I was thinking, like if they've just got a bunch of YAML, then we should be able to apply that. Right? You shouldn't need anything special.
Yeah, I definitely agree on that. Just like the number of projects out there that just have like a file with a bunch of YAML in it, that would be very user friendly. So I'm glad that you think so as well.
Yeah, I think forcing people to have to add another tool into their toolbox if they aren't ready for it or don't want it yet,
Yeah.
is going to make adoption of it harder.
Mm-hmm.
So giving people a step into using something like this by saying, yeah, you've got your YAML, we'll apply it.
Mm-hmm. Yeah, I can add a section to the proposal portion here mentioning desired support for manifest list. And we can do that from a local file or from a HTTPS endpoint, or just any HTTP endpoint, I suppose.
So is that the, sorry, go ahead, Justin.
Sorry, no, you go ahead, Justin. Bye.
I was just going to say, is that the manifest for the operator or the manifest for the thing that the operator would apply? Or, I mean, are you sort of bypassing operators?
I don't think that this subscribes to being like, oh, something should or should not be an operator. A good example is in the case of kubeproxy, right? Like we chatted in our last meeting about how this has a bootstrapping issue, right? And there's also very little customization that is necessary for kubeproxy. Most users couldn't get away with just installing a manifest list. Core DNS is different though, right? Where you need some kind of smarts to be able to inspect the cluster's networking things. And so this could be an operator. And this is the manifest to install the operator plus its RBAC. And then like for something like WeaveNet, all we have is a manifest list. But we've talked about several use cases, including the uninstall, that may benefit from an operator.
I do want to add that I actually am in the process of writing a kubeproxy operator. So it is a solvable bootstrapping problem. You can schedule around it, but you do have to detect the API server, essentially, detect its location, which right now, we kind of accomplish in kubeadm that configures that endpoint, but we need to figure that out in a different way.
Yeah, I mean, so what you're looking for is to find out how to, yeah. No, maybe we can, do you want to talk about like how that would work?
Yeah, right now I'm just running it locally, so I'm doing just like running the operator. But you can ignore all the scheduling tolerations, the not ready scheduling toleration, and stick the operator on the master, which is probably where it belongs. So if it's running part of the control plane, I mean, it's the thing that provides a lot of those network facilities, but you can do just about anything otherwise, as long as you're referencing the API server directly. But you can set up a service account and that sort of thing. Without any sort of networking features.
By talking directly to the API server using its external IP address?
Yeah, or just like localhost was also by bit. And then the thought around that, I mean, there's two sides that you can say, well, it's not necessary. kubeproxy is relatively simple. There's not too much configuration. But the reality is, like, if you want to start exposing, kubeproxy is like really inherently tied to the release. So being able to sequence its upgrade and have sort of a health and status sort of along with it, I think is really where it starts to get interesting and starts to be a little more justifiable of having that extra component there.
I think I can heavily agree that implementing a daemon set rolling update would be smart. I don't know. I would imagine that our guarantees for kubeproxy support are n-1, right? So we probably upgrade the kubeproxy daemon set before we do all the kubelets, I believe, is how the kubeadm upgrade works. How true that is in practice, I don't know, but I don't know if there's ever been problems with a kube proxy not supporting an older cluster node. I can't imagine why that would be and what relation it would have to the kubelet, but that is a thing.
Yeah,
but
I just want to illuminate that I think it is a potential use case, and I agree. I don't think this needs to be prescriptive about operator or no operator. I think there's room to make that decision, I think.
But yeah, with regard to operators, I'd say that this is the way to get an operator into the cluster, right? In a user facing way.
And on the CRDs as well, where would they live? Like if there was a core DNS CRD, would you imagine that would be in the manifest that you've referenced, or would you put it as another object in the kube ADM configuration?
I would be fine to bundle the CRD inside of the operator itself. And then since the operator and the CRD versions are going to be pretty coupled, I would say. And then to have another component afterward, right, that installs the component config or the custom resource for that thing.
Sorry, yes, I got confused between a CRD and a CR. So who installs the CR? Sorry.
It could be bundled in, or it could be another component. With regard to kubectl apply and delete, I think one behavior we would want to, I imagine it's already been thought about and it does it in a reverse order and ordered fashion. But this list is specified to install in order, which means that you get a blocking behavior on the API server. So like if you want to like install some manifests that from an API standpoint depend on some other custom resource definition being installed, you can do that in order and then expect that it'll be undone in the same order. But which for something like this, right, like I guess it makes like logical sense for other components as well, but there's actually nothing that would necessitate that these components, these particular examples, would need to be installed in a particular order because there's no API dependencies between them, but it just makes logical sense as well to list it in this order. So, and, there is one proposal in here that I currently just have out of scope, which is, where did I put that? Oh, it's not formatted nicely. Okay. Basically, this is the proposal about uninstallers. We could add a reference to a separate manifest list or customized that on install is, or when the add-on is sensed to be removed, right? So it's declared when it's installed, and then when it's removed, it's applied. And we can block on like the job object or something before quitting. So
you can also use a finalizer.
A finalizer. What would, I guess the operator could install a finalizer on itself and then satisfy the finalizer?
Not necessarily on itself, but on the CR.
On the CR. So I guess that would just have to, like, if you had the CR come, like say there's core DNS operator, and then after it there's the core DNS CR. Then if you were to uninstall both of them at the same time, the CR would be ripped out first, then there would be a finalizer, and we're still waiting for that to be removed. It's a blocking operation. So then the operator has a chance to clean up the finalizer, and then we can move on to removing the operator.
Yeah, I don't know if there's a way to enforce that nicely. But yeah, I don't know. But yes, assuming you don't delete the operator first, then yes, that it becomes easier. But yes, I don't know how we would enforce the don't delete the operator first rule.
I think if you're trying to delete the operator, it's going to fail because the CRD cannot be uninstalled with a CR present.
Is that true, or does it delete?
Is that a new feature? Because I know I've gotten myself into trouble just like deleting the CRD.
I thought if you deleted the CRD, it cascaded deletion of the CRs.
Oh, does it?
Am I wrong?
That could be on old Kubernetes though.
I thought that was true.
But let's assuming that's true, and assuming the finalizer is fire. If we arrange to delete the CRD first, we won't complete deletion of the CRD until the CRs have been deleted. In which case, the finalizer, so it must have been, so the operator must have removed the finalizer. So maybe.
Yeah. The only thing is, my only question would be, like, if they're all in the same bundle, right? So if the CR is inside of the operator manifests, then that would make me think, well, it depends on kubectl's delete order.
It seems like we could order this if we added some more fields here to actually specify some things, or maybe inside of a given reference and manifest, we have a defined structure that says like this file here means a certain thing. Like, at least in my mind, maybe we put some more structure around this rather than just giving a blob of stuff and then trying to snuff out what we're supposed to do.
Mm-hmm.
Actually order and make things more structured here.
Yeah. I would also just be like suspicious of adding orchestration fields when there are potentially simpler rules, like always dealing with CRDs first or last, right? Depending on whether you're applying or deleting. And I just don't know if those rules are present in existing components currently. But
right, I guess I'm also like a little worried that like maybe for a given operator, let's say like we add it as an install and then the user removes it, but they didn't mean to, we delete all the data, right? When you delete the CRD. So maybe they want to keep that around. Like maybe we want this to be a little bit safer and we just delete the CR that like it's for the given install. Like I'm imagining cases where we might want to have more control for the given cluster admin as they're building this stuff to specify what they want to happen.
yeah, I'm personally very for CRs being their own add-on. Like installing the operator and installing the CR to me are very different things. So I would say in that case, like where you want a user to have control over their installation, but then like have independent control over the operator, I would say that should be like the default and like canonical best practice. Because you lose like granularity in the abstraction if you like say you're providing an add-on, like say you're a company like SIG or Weaveworks or something, and you have a default installation that you want people to install, and in the very base of your add-on, right, like it's always installing the default. Since things like customize are always additive, like it becomes very difficult to prune the default custom resource from that definition. Like it should always be an opt-in thing.
think that there's kind of, Sean, when you said that, I was kind of thinking if we had a structure that was explicit about sort of groupings. So not necessarily saying that a package has these three things, has operator, CRD, and CR, but saying that we have sort of groupings of refs that say, hey, this is the operator, this, or if we have one, right, this is my raw manifest, this is my CR and my CRD, and we can be very explicit about how we handle the ordering of those components. I think that it's something to consider, like, how much orchestration do you want to do with this? I think that operators need some level of that, or else we end up having to write all these big operators. So having just sort of a base set, kind of a simple set of behaviors around these groupings, I think could be useful. Like, I think that could buy us some benefits.
Something kind of more along the lines of this, right? So like here we can grab like from customize, and I guess like this could even be organized in this tree a little bit better.
Yeah, I'd even put like guardrails around that instead of just making it blank refs, making it like a CRD, like a CRD section or something, and then like actually making each one of those a section. So name, coronet, core DNS, and then you have the CRD ref, the CR ref, the operator ref, or something along those lines. I don't know how to make that like generic. I'm just thinking out loud here because that would give you more structure. That would allow us to make decisions about things and maybe change things if we find we need to, or something along those lines. But just thinking out loud, I could be way off.
So something like so because these refs no longer have names that are independent, I'd say this makes this difficult to figure out when you remove something.
I think we're talking a step further. So not just list of refs, but ref, type or ref name, operator, something a little deeper into your. I agree. Yeah, if you just have this string sort of URL, then that's that replacement problem when you swap it out with your own implementation.
Yeah, that's like definitely the main use case you'd want to like support, right? Is for people to be able to fork, right? And so I need to be able to like take Kubernetes SIGs here and then put like my own username, and that's not a removal. Like nothing's being uninstalled there. So I'm not against this. This seems fine. You would just nest into this and then install these.
Maybe instead of a name, a type, we have like a defined list of types for them.
Yeah.
So like we know what they are. I don't know.
I mean, I guess we can support the operator use case as like a first class workload, but it just makes me think that like people are going to want to split up and compose their add-ons in other ways. Right. Like this could just easily be like daemon set or agents or driver.
Yeah. So an approach we took for some of our core stuff, we had a handful of special cases like create the CRD before the CR. So if we see a CR and that like creation is failing because the CRD exists, we like wait and come back to that one. And we have this concept of like run levels. So it's simple, but it works, right? It uses a numbering scheme, and then anything in the same run level can all be spit out at the same time. And if for some reason some part of the run level fails, it'll keep retrying until it gets to that whole run level. And then it'll move on to the next one, and then it'll move on to the next one, which also gives you that parallelism that a straight serial doesn't give you. So it's like a combination of having serial levels with parallel creation inside the level.
Yeah, kind of like a initRC style of execution, right? Where instead of calling this a serial list of applications, you would do all of them at the same time with a pipeline, not necessarily a DAG, but like an ordered pipeline where you're like, oh, okay, well, here are all of my zeros, and then let's, then do all of the ones, and then do the twos, that kind of thing, right?
Yeah, because the reality is a lot of them aren't dependent on each other. They just all need to get created. And so you actually make things take a lot longer if you force everything to be in serial.
Yeah. And then that just has an effect on logging, which is not a big deal because you just batch all of your errors and stuff until the end, right? And, I mean, I kept this as a serial list because it keeps the implementation simple and blocking. But I'm totally down to implement something like that, either with a DAG with like a dependency and like a list of names or something. And so this could be like, now, if there's any kind of nesting in here, I guess you'd have to be like, you could support that, right? But yeah, either with the DAG or with the phases. That's something that could definitely be expounded upon in the KEP. And Jessica, you were saying that you guys, that's the feature that you built in OLM, right?
This is stuff in our cluster level operators. Hold on. I'm just grabbing a link.
Mm-hmm.
So this cluster version operator, when it goes through and applies everything, it's constantly reconciling this stuff, which was actually another question I was going to bring up. When it's going through a list of manifests, it's looking at them. It uses alphanumeric naming, and the numbers prepended to the files help it determine its run levels. Like, it's about as simple and straightforward as a system for how do you know what order to put things into the cluster. Like, it can be handed just a pile of manifests and decide what to do with them based on that scheme.
The run level, are they?
Yeah, let me show you an example.
Yeah, sorry, I try to figure out how to link. More chat. Here we go.
Find an example.
Cluster version operator. Yeah. Tests.
So if you look at the link I just pasted, it'll be a little more obvious what I'm talking about.
Okay.
So like in this case, when all of these manifests are included, they're in our run level 70, which is number 7, basically. So that one for us just means the one where we've got Cube API servers up, and generally everything can be just applied to the cluster at this point. This is, for the most part, the point at which a cluster is largely provisioned, and we can put a bunch of extra stuff into the cluster.
So I noticed
so
that there was this namespace right here has a run level in it. Is that useful? Like, is this used?
I'm actually not as familiar with that part of it. I have to check back and see what they're using that part for.
Yeah, I guess just the only difference that I would perceive would need to occur here is that this level, if that's what this is in the manifest name. And then this is inside of the manifest itself. And these would probably need to be defined at the user level right here, like in the configuration about the add-on. That's I guess my only.
Sure. Yeah.
But then,
we did it this way. There are definitely other ways that you could do it.
Yeah.
Just as this works well for us from the perspective of being able to put a lot of things into the cluster at the same time.
Yeah.
When you start talking about really big clusters with lots of things needing to get installed to them, doing all of those in order could take hours.
Yeah, I mean,
to wait for every single thing to come up and all the images to get pulled to the cluster and all that.
Yeah, and you also wait for you have like a full status that is able to understand the status resource of things that are popular, like deployments and stuff, right?
Yeah, our operators actually have a status object. I think I've shown you guys that before, our cluster operator object, where it can say whether it's available and ready to go yet or not before things move on to the next stage.
Yeah. Because this would be just applying manifests and waiting for them to be okay in the API server and then moving on. But then doing something smarter than that, right?
Yeah, so that's a good point, actually, Lee. So in this case, if there is actually dependencies and these are put in order for a reason, because things need to boot up and be running before moving on to the next one, how would you do that in this setup that you have right now?
I would probably need to think of like a more concrete use case, because most things, like the only dependencies that I can think of that prevent you from applying resources to the cluster are API dependencies, right? Like the API server doesn't know what you're trying to tell it to do. Or it doesn't know what you're trying to declare, right? So if you try to apply a custom resource before the custom resource definition isn't there, then like that's not going to work. But like if kubeproxy never comes up, that doesn't prevent core DNS from being declared into the cluster. Now, because kubeproxy does not come up, core DNS is not going to work, but it will have the cluster declaration there for the user to debug with. And this is a real state that you can get into with Kubernetes right now. And similarly, right, if kubeproxy is not up, like you're going to have a hard time installing CNI and for it to actually work. But there's nothing wrong with declaring the CNI manifests into the API server, and you could do that even before kubeproxy exists.
Yeah, I think part of the difference here is that we are using the same system to get the cluster itself up and running. I also think that we're using it in a few places where so the network goes in an earlier run level so that our network is up and stable and working across the nodes before we start doing some of the other components. So the one I pointed to here is actually our routing, and not like the SDN, I believe, if I remember correctly.
That's in manifest list here. Yeah, network operator.
Yeah, we have multiple parts to our networking stack, and so some of them go earlier than others. And I think the other case where we try to be careful to prevent flapping in the cluster as operators come online and start injecting their view of the world into the cluster and doing what they see as configuration, where operators may need to communicate with each other. We actually have a number of operators that will read their own personal configuration to the cluster and then write out configuration for other pieces of the cluster to read from, and then configure themselves based off of. So as things are coming online, we don't want things rebooting 10 times as everybody else comes online. So things that inject a lot of change into the cluster tend to go sooner.
Interesting.
I think it largely depends on what it is you're talking about and how many things are going to be in these clusters. If it's like, if you're in the order of 3 operators, maybe not that big of a deal, right?
Yeah. So for and most of these things, can they be like looked at like, could we synthesize an example from open source OpenShift of like a bunch of stuff?
Yeah, I'm trying to think. Our most dependent operator is probably our UI, I'm thinking, because it relies on a number of different pieces in order to get to the state where it's configured correctly. Like it relies on configuration coming from the API server, it relies on stuff coming from our OAuth server. There are a few different pieces that have to be online and configured before the console is ready to be used by an actual end user.
Yeah, because like if it were possible and could be done with just like a very simple dependency mechanism to install OpenShift with this API, like that would be like probably like the biggest use case that might be available, right? Like that might be the most complex example that we could target. And there's either with run levels or with hooks or with dependencies, like there might be a simple way to make that a workable solution.
I mean, I think for us, right, the way that we deliver this stuff is not through Git repos. We're delivering the stuff to clusters via images.
The
actual manifest content.
The actual manifests themselves are in an image. Yeah.
Mm-hmm.
Yeah. Which is another facet of this that I think several people agree should be supported. Well, and Evan built that customized packaging POC, which is probably a good start in that vein. I'm not sure.
We also have we have a operator bundle proposal that we're iterating on. I don't know, Sean, if you're still on, if you have that one handy, I can try and find it.
Yeah, I can grab it. Give me 1 second.
So I think I found it. It's number 27.
Yep, that's it.
So this is a standard and convention for storing operator manifests and metadata as container images. So these are just normal Docker images
Yes.
with stuff in the root file system.
Yes.
So when you unpack it, then you have stuff.
And Sean, I don't know if you want to go into more detail
I
on
mean,
that.
no, that's pretty much the gist of it. I know that we just got the 10-minute warning, so I don't want to maybe sidetrack this enough. If you guys would want us to present some of this, we can maybe next meeting.
I'm interested in this proposal, like, because I think that this is a very simple way to assemble manifests, and it uses tooling that people understand. It does rely on convention, as opposed to like what Evan wrote up, which is storing layers that are not actually intended to be a file system.
Yeah, so the concerns with approaches like that are one of current tooling, right?
Yeah.
Anything new, we're fighting against the already existing tooling in every single enterprise environment out there, and getting adoption for new tooling, it's always a hurdle. So for something that could work today in any of these shops out there, what makes sense? Like, what do the registries already support today, right now, in all of these environments? What do the tools already support today, right now, in all of these environments?
I love
there's
that
a little
you
bit
just
of a
the bash example here with JQ in order to cat out the layers so that kubectl can use them.
Yeah. So, and I think, I can't remember if it ended up in the enhancement or not, but the thought went into this of how could this transition to an OCI format as everything gets into that world, as all the registries start coming up to date, the CLI tools come up to date, et cetera, et cetera.
Yeah. Oh, and this is even more recent than Evan's proof of concept here.
Yes.
Okay, so kind of like this started happening kind of aside or in lieu of or after some of the conversations that we already had here about having a desire to distribute bundles in this way. So maybe this is something that we can adopt, considering that in the upstream, this could be an example of something we could upstream.
I think that would be awesome. If it makes sense, we'll totally, I think in 2 weeks, we put on a thing to present this and start talking about it.
Yeah.
Since we're getting close out of time, I think we would love to do that and love to have those conversations if people are interested.
Yeah, let's definitely put this on a demo reel for next meeting. And I don't know if we want that to really be a productive conversation. I imagine we should ask somebody from like SIG architecture or from cluster lifecycle to come and say that sounds sensible. Because definitely, if we're going to be talking about like distributing a new kind of artifact, and it requires like some canonical usage of images, but for good reasons, then like just getting a little bit of buy-in so that we can actually get something merged in an experimental like kind of alpha support would be really cool. Yeah. Okay. Thank you so much for really providing good feedback and asking questions that move this forward. Everybody, this is super helpful. So.
Yeah, thanks, Lee, for your work on this. Really interesting how writing this up sparked so much discussion, and everybody can much more easily imagine what the future is going to look like. Do you need any help with anything or any more specific feedback you need?
Yeah, I mean, we have this recording, but like if if you have like something particular that you asked a question about, or like wanted to propose something, like different API changes, like Jeff, I know you were mentioning some things with this grouping, just getting that conversation going on the CAP would be really helpful. Even just like a stub, and then we can fill it out, you know. And yeah, then we can get those things upstreamed into the library, merge the library, and then get a real implementation working.
Super.
Cool.
Thank you,
Anything else
everyone.
from anyone? All right. I guess we can wrap it up. See you again in 2 weeks. Thanks, everyone.
Thanks, everybody.
I guess.